Hi guys, welcome back to my mathematics tutorial. Again, my name is Peter C. Dogba Jr., your math tutor, and I'm also an instructor of mathematics at the University of Liberia. So in this lesson, we want to look at some other problems. Like in previous lesson, we did the first three problems on the chain rule. So we want to solve additional problems, like four additional problems under the chain rule, and see how it works. And in the next one, we're going to solve additional set of problems again that combines the chain rule, the product rule. Some of them combines the chain rule and all of the quotient rule and everything. So let's look at this problem first. Okay. So the first problem says f of x is equals to 1 over 3x squared plus 5 raised to the fourth power. So now you are the one that will solve the problem. It's not me. You can decide how you reword it and determine the most difficult portion of the problem. Because the most difficult portion of the problem is what you try to simplify in a form that you can allow certain portion to be a single variable and the rest of the other portions to be another variable, such that when you find the derivative of both of them, you can multiply them. So what am I saying? Look at this problem. This problem, we can rewrite this problem as 1 all over 3x squared plus 5 raised to the fourth power. Because we know that 1 raised to the fourth power is the same 1. So we can rewrite it like this. Then our u can be 1 all over 3x squared plus 5. Or we can decide to say this will give us tough terms. Let's look at it being u equals to 3x squared plus 5. So only this we are dealing with, such that 1 over u raised to the fourth power will be something that we can easily deal with. So you can either approach it this way, wherein everything in here will just be your u to the fourth, or you take only this portion and allow whatever down here to be your u raised to this fourth power. So that's what I meant when I said you are the one solving the problem. You know what substitution to carry on. So if I may advise, take what is within here to be your u, because assume that this expression was some kind of like 7 terms, right? And if you're using the quotient rule after you have rewritten it like this and you want to use a quotient rule, it might just give you tough time. So take what is in here to be your u. So we say let u equals to 3x to the second power plus 5. So our du by dx would just be 3 times 2 is 6. X, this is 0. So we've gotten the first one. The next thing we need to get is our dy. So the first thing, let's know the new function, right? So this is f of x. So we can just rewrite that f of x as y. And this is 1 all over. So what is here is u. So it's u raised to the power of 4. Two ways we can solve this. We can differentiate this problem to find our dy by our du. One could be we send this in the numerator. That is, we rewrite it as u to the power minus 4. And then we differentiate this one. Or we leave it like this and apply the quotient rule. So to apply the quotient rule here, we hold the denominator, u raised to the fourth power, and we differentiate this one. It gives us 0, right? Minus, we hold the numerator 1 and differentiate the denominator. So the derivative of u to the fourth power gives us 4u, and then we subtract 1 from this power, remains 3. all divided by this same u to the fourth power raised to the second power. That's the rule, right? So this one is out. dy by du is just equal to minus 4u to the third all over u. Now 4 times 2 is 8. So this u cube can go out because we take the cube from within this 8. We're left with u to the fifth power. So we will have the u dy by du to just be equals to 4 all over u to the fifth. So we've gotten the two of them. Let's put them in now. So we know that dy by dx is equal to du by dx. What is du by dx? 6x times dy by du, 4 over u to the fifth. So we can just simplify now. Remember, our original variable is x. So we have to get rid of this u by bringing in the value for u. What was u? U was 3x squared plus 5. So 6 times 4 is 24x all over 3x squared plus 5. So this is it. So let's do the next problem. So question 5 says y equals to x plus 2, x minus 3. Now both of them raised to the same power. So we can rewrite it as x plus 2 divided by x minus 3 raised to the second power. So our objective now is to ensure that what is within here be a single variable. So we can say let u equals x plus 2 all over x minus 3. Then we differentiate this. You see that this will be easier to differentiate than differentiating this entire expression, right? So we find the u by the x, the quotient rule. We hold the numerator, the denominator, x minus 3, and we differentiate the numerator. So x plus 2, the derivative of x is just 1, derivative of 2 is 0. Minus, we hold the numerator now, x plus 2, and differentiate down here, we have 1. Then the rule says we must square the denominator, that is u minus 3 all square. So the u by dx is just equal to, now this x minus 3, and this negative x, and negative 2. So it's x minus 3 all square. So this x cancel this x, we're left with minus 3 and minus 2 is minus 5 all over x minus 3 raised to the second power. So we don't know the first one. We now move on. Now there's f. So we can replace this f now with y. Okay, sorry. This y already. This is the function we're using. So this inner portion is just u. So it's u raised to the second power. So what do we need to find? dy by du. So what is this? This is 2u, right? So try 1 from the power is just equals to 1. So now we can find our final answer, which is dy by dx, which should give us the product of du by dx and dy by du. So this first one is 5, negative 5 all over x minus 3 raised to the second power times, this is 2u. But again, what is u? From the beginning, we saw that u was x plus 2 divided by x minus 3. That was u. So we have minus 5 all over this x minus 3 raised to the second power times 2 times u x plus 2 all over x minus 3. So we can further simplify that by saying dy by du or dx is equals 2 times 5 is 10. So this is x plus 2. So just do it like this. Divided by. Now down here we have x minus 3 raised to the second power. And this is x minus 3 raised to the first power. So when you're multiplying like bases, you add the power. So it's 2 plus 1. It gives us x minus 3 raised to the third power. So this is our final answer. So let's look at the next problem. I'm going to erase this. So the next problem says y equals to the square root. So that square root now I'm going to rewrite in terms of an exponent, which is 1 over 2. So it's x plus 2 all over x minus 1. It's similar to the one we just from doing. So within here, we say let u equals x plus 2 all over x minus 1. So we find our du by dx. So du by dx is just equal. Now we apply the quotient rule, right? Again, the quotient rule says we must hold the denominator first, x minus 1. And then we differentiate the numerator. So the derivative of x is just 1. Minus, we hold the numerator now, x plus 2. And differentiate the denominator, which is just 1 as well. Divided by x minus 1 raised to the second power. So if we further simplify du by dx, this will give us x minus 1 minus x minus 2, x minus 1 raised to the second power. So x and x go out. Minus 1 minus 2 is minus 3 all over x minus 1 raised to the second power down here. So this is the u by dx. Now, this is y now equals u raised to the power 1 over 2. So dy by dx by du is just equal to, we drop this power 1 over 2. Subtract 1 from this power. So it's 2 times 1 is 2 all over 2. So this gives us u raised to the power negative 1 over 2. So if we want to rewrite it, we can bring it in the denominator because the power is negative, so that it becomes positive. So it's 1 over 2. So the final answer now, we have dy by dx is just equal to du by dx times dy by du. So du by dx is just negative 3 all over x minus 1 raised to the second power, and then times 1 over 2. Then this u, what is u? U is x plus 2. So remember, u is down here, right? So it's x plus 2 all over x minus 1. That is u raised to the power 1 over 2. So we have to simplify that, right? Further. So we have dy by dx equals minus 3 over x minus 1 raised to the second power So each of them can be expressed, can be raised to their own powers. So we have so this 2, I bring this 2 on this side. So we have 1 all over x plus 2 raised to the power 1 over 2 divided by x minus 1 raised to the power 1 over 2. So we have to simplify that further. So we have dy by dx is equals negative 3 all over 2x minus 1 raised to the power 2. Okay, now let's do this. This is x minus 1 raised to the power 2, and this is x minus 1 raised to the power half. When you have okay, so I just bring this one under this, right? Divided by x minus 1 raised to the power 1 over 2. When the bases are the same, you have a raised to the power 2 divided by a raised to the power 3. The rule says we must say 2 minus 3. Why are we saying 2 minus 3? Because this a, we can send this a raised to the third power in the numerator. So it will be a raised to the second times a raised to the negative 3. So when the bases are the same, we multiply, we add their powers. That is 2 plus negative 3, which is 2 minus 3. So because of this rule, we can apply the same thing here. So it's this divided by this. So now we can say 2 minus 1 over 2. So times x plus 2 raised to the power 1 over 2. So that is the whole numerator. Let's say the denominator now. Then we further simplify dy by dx is equals negative 3. So what is here? 2. Now 2 times 2 is 4. 4 minus 1 is 3. So it's x minus 1 raised to the power 3 over 2. And then times x plus 2 raised to the power 1 over 2. So there's the answer. We can stop here. You don't need to bother yourself about rationalizing and disturbing yourself in that manner. You can just stop right here, right? So there's our answer. Or better still, maybe some students will say, no, Brother Peter, we want to further simplify that. Better still, this one. Dy by dx is equals to negative 3 all over 2. Now this x minus 1 raised to the power 3 over 2 means x minus 1 times x minus 1 times x minus 1. The square root. That's exactly what it means. Because the root, the number in the denominator represents the root. So it's like 1 over 2 raised to the third power. So there's it. Times the square root of x plus 2. So we have dy by dx is equals to negative. So it's 3. Now we can take the square root of each factor, x minus 1 times x minus 1 times x minus 1 times the root of x plus 1 is 3. So dy by dx is just equals to negative. So this and this, the root cancel. So you have 3 all over 3 times x minus 1. And this, what happens? It is the same root. So we can put it under the same root. X minus 1 times x plus 1. What is x minus 1 and x plus 1? That is x squared minus 1. So you can keep it like this, or you can rewrite it as x squared minus 1. So this will also be your answer. This is correct. This is also correct. It doesn't matter. We're just trying to simplify in a way that maybe you want to simplify in a different way, and another student will want to simplify in a different way. Another student will say, I don't want a square root to be in the denominator, and that student can get rid of that square root from the denominator. It doesn't mean that your answer is wrong. All of your answers are correct. Our basic concern in this problem is to find the derivative and simplify it at least so that it be in a compact form. So another student can say, I want to get rid of this square root from the denominator. So you can rationalize this. You can rationalize this. So it will be s squared minus 1 divided by s squared minus 1. So what happens? It's equal to 3. I think 1 was 2, right? This is 2. Okay, so down here is 2, not 3. Okay, this is 2. So another student will say, no, I'll just get rid of that. So that becomes the root of x squared minus 1 all over 2 times x minus 1 times x squared minus 1. So it makes no difference. It's just rewriting the problems in different ways. So let's look at the last problem quickly. So the last problem says y equals to the cube root of 4x squared plus 3 raised to the second power. So in exponent form, we can rewrite this thing as 4x squared plus 3 raised to the power 2 or raised to the power 1 over 3, because 1 over 3 now is a cube root. So if we multiply these two, we just have 2 over 3. So now we can allow our u to be what is inside. It makes it very easy for us. So we say let u be 4x squared plus 3, and then the u by dx will just give us 4 times 2 is 8x. The derivative of this gives us 0, right? Then we move to rewriting it. So if we rewrite this now, it becomes y equals to u raised to the power 2 over 3. So what is the derivative of this? dy by du will just give us 2 over 3. We drop 2 over 3, rewrite u, and subtract 1 from this power. So the same shortcut method, we say 3 times 1, so it's 2 minus 3 all over 3. So this becomes minus 1 over 3, because this is minus 1. So we can say let's reciprocate. So that is dy by du is equal to 2 all over 3 u raised to the positive 1 over 3. So finally, we can write the final form, which is dy by dx. And what is it? Du by dx times dy by du. So du by dx is just 8x times dy by du is 2 all over 3 u to the power 1 over 3. So dy by dx equals 8 times 2 is 16x. Then it's 3. U now is 4x squared plus 3 raised to the power 1 over 3. So this is our final answer. So thanks so much for watching, and see you in our next lecture. Please don't forget to subscribe to our channel. You can like, you can share it, and hit the notification button so that whenever we upload, you can be able to get new uploads from us. Thank you.